All right, this is Chapter 6 review. We're going to go over every single section and talk about what the main idea was. This is also page 279 in your textbook. All right, so section 1, we talked about relations versus functions. We said that it's a relation if there's an input for an output. So basically, anything is going to be a relation. But now only certain things will be functions. It will be a function if it has every input has exactly one output. So for example, this would be a function because you see how the -2 goes to the -1, 0 goes to the 3, 2 goes to the -1, and 4 goes to the 5. It's okay for the output to have multiple inputs, but it's not okay for an input to have multiple outputs, okay? So I would say that this is a relation. I would also say that this is a function. Okay? So section 1, that's all we talked about was relations versus functions. So number 1 right here, this is what, you guys? What do you guys think? Good, this is a relation. Oops, I spelled relation wrong.
Versus screaming on the toilet.
Remember how I said I'm recording this? And to not talk? Yeah. It's a relation, but it's not a what? It's not a function, and tell me why, because they will say explain. Why is this not a function? Very good. 7 is going to the 6 and 7 is going to the 8. You can't have that happen, okay? The inputs can only go to one output, okay? So this is a relation, not a function. How about this one? It's a what? Good. It's a relation and a function. Now, why is it a function? Very good. Every input is going only to one output, right? Okay, so that was all of section 1. Pretty simple. Do you guys agree? Okay, section 2. We talked about representations of functions. Now, this is where we talked about having an equation to represent the function, right? Okay, so if I have this equation, and I told you to use these numbers right here as inputs, could you find me the outputs? Remember, inputs are x's, right? Outputs are y's. How could I use these numbers to go find the y's? Very good. Plug them into the equation. Now, if you look at this table, that's what they did. I'll grab my little guy right there. These are the inputs we plugged in. This is the equation we plugged it into, right? So it would be -1 minus 1 equals -2. So on and so forth, and here's where we got for our outputs. Now remember, an input and an output are just x and y, so are these ordered pairs? Yeah, -1, -2, 0, -1. I can take those ordered pairs and now plot them, okay? And once I plot them, I can tell if that's a relation or if it's a linear function or all of that, right? What do you guys think about this? Is this linear or nonlinear? Good, that's linear. So section 2 is just about representations of functions. Let's talk about 3, 4, and 5. We did these yesterday, right? Okay, I'm just going to give you a quick little recap of how to do these. So you would say, here's the equation, right? They're saying what would be y if x was -4. So plug in -4 for x. This would be y equals 2 times -4 minus 3. 2 times -4 is -8. -8 minus 3. Signs are the same, so we just add 8 plus 3 is? Very good. That's how you would solve for 3, 4, and 5. Now let's look at 6, 7, and 8. We did these ones together too, right? Yesterday? These say to graph the function. You can graph a function if it's in y equals mx plus b, correct? Is this y equals mx plus b? Yes. Who is the y-intercept? 3. Who's the slope? 1 over 1. Very good. What is the y-intercept?
0.
Good job. What's the slope?
-5.
Over 1? Very good. How'd you graph this guy? Where's the y-intercept?
-3.
Good. You guys did not get tricked by that yesterday either, that they swapped the two, right? That's the y-intercept, and what's the slope?
-3.
Good job. I'm really, really happy that you guys said -3 over 1 and not 3 over 1. Very nicely done. All right, that was all of section 2. Let's talk about section 3. We did not talk about section 3 yesterday, so this is all brand new for us. Ready? Use the graph to write a linear function that relates x to y. The points lie on a line. Find the slope by using points 1, 1 and 2, 3. So they're saying, we gave you this graph. Now tell us what the function is. Remember, the function is the equation, right? Do you see a y-intercept? Remember, a y-intercept is when it crosses the y-axis. Okay, so what's the y-intercept? -1, right? So in my equation, y equals mx plus b. You guys just found b. You said it's -1. So I'm going to have y equals something x minus 1. I need to go find m. How do I find slope? Good. I like what both of you said. Addie said, you were about to say just count, right? Just count. You said y2 minus y1 over x2 minus x1, right? Okay, either one of those with this table, this chart, would work great, right? I'm going to do Addie's first. Addie just says literally, let's count from this point to this point. Ready? 1, 2. So it's up 2 over 1. So the slope is 2x, okay? Now, let's say they gave you some crazy ambiguous numbers that were like 107.2, comma 11, and this one was 96.5, comma 10. Like, what if these were crazy numbers and you didn't want to count all of that, right? Then use Preston's handy dandy, oops, not y, sorry, m, which is slope, equals what again? You got to remember, y's go on top, okay? Then you could say, okay, let's take 3 minus 1 and then 2 minus 1, right? And then we'd get slope. If you forget this formula, you're going to be in a world of hurt because sometimes they're going to give you a table like this and say find the slope. And you don't want to graph that, right? You don't have to graph it. I'll show you in a second, okay? Okay, so here would be our answer. What are some different ways I could write this answer? Okay, so I could say y equals -1 plus 2 over 1x. Okay, what else could I do? Could I say y equals 2x plus -1? Yeah, or y equals 2x minus 1. All of those are the same answer. There is one that's more correct than the others, though. Do you know what it is? You're close. Good. This one is actually more correct because it's considered simplest form. I don't have a 1 right here, and I don't have a plus and negative. Okay? So I will accept any 4 of those as an answer. Just keep in your mind, though, that maybe one day when you get to high school, they might want a more correct answer. Okay? All right. Graph. Use the graph or the table to write a linear function. Just like what we just did. Find me b. 3. Okay, so I've got y equals something x plus 3 or minus 3. Good job. Now, how do I find slope? Yeah. Let's count. Up 1 over. Very good. There you go. That's the function. Function rule right there. Okay? Yeah, we could do that. You could use the rule for then too, right? Yeah. When you guys are doing this on the test, you know what you need to really be careful of? The scale. Remember how sometimes in our homework the scale went by like 5s and sometimes went by 3s and sometimes it was just crazy? They were very, very kind to us and gave us a scale of going by 1s on each of these, right? But sometimes they're not so nice and we have to keep our eyes peeled for that, okay? Would that change the slope? It really would. Okay, number 10. Here's the one, the last quiz we took. Some of you guys kind of struggled on this. Remember, we're doing the exact same thing we did over here. We're looking for a b, we're looking for a slope. Ooh, why do you think -7 is your y-intercept? Yeah. Yes, if you see any ordered pair, because these are all just ordered pairs, right? If you see any ordered pair with a 0 in the x, the other number right here, that y, that's going to be your y-intercept. So do I have a 0 who's in the x? Yeah. So there you go. There's your y-intercept. So I have y equals something x minus 7. Now, how do I find slope? Yeah. Very good. We use what Preston was saying, y2 minus y1 over x2 minus x1. Now, sounds complicated, but look how easy this is. Go to your y's and just subtract them. What's -7 minus -7? This is a double negative, right? So it's actually -7 plus 7, and Addie, you say that's what? Okay, so my y is going to be 0. Now go to my x's and minus them. What's -2 minus 0? -2? That's it. On the quiz from, gosh, what was it, a week ago? If you guys made a mistake, it wasn't that you couldn't find the y-intercept. It was that you accidentally put your x's on top of your y's for your slope. Remember that? Yep. So you have to be so, so careful. You do your y's first and put it on top, and then your x's and put them on bottom. Okay? Now I have a question. This line right here, what would it look like? Ooh, okay. It's not undefined. Undefined is in zeros in the denominator. Slope is 0, right? And you guys know that if slope is 0, that means the line's going to look something like this. Is that still a function? Very good. That is still a function. All right, that was 6.3. Any questions about 6.3? Should we move on? Do you feel confident? Yeah? All right, 6.4, comparing linear and nonlinear. You guys did such a good job on these. If something is linear, your x's and your y's will have a pattern that's constant, right? As you can see, the pattern for my x's is constant. Yeah, but my y's screwed it all up, right? So this would be a function, but it's a non-linear function. Good. How about this guy? Yes, it's what? It is. It's a function that is linear because the 5s are constant, the -10s are constant. That's great. On the quiz and on the test, this is not a yes or a no question, you guys. This is is it linear or is it non-linear? Okay? It's okay, Addie. You can go in the hall if you want to do it. It's okay.
I just want to be in the video.
It's okay. They
I
won't.
don't care about doing it for you guys, but that's
Your blowing your nose will forever be on YouTube now. Okay, you guys have any questions about either of those? Pretty simple? Okay. We're going to go on. These are the example problems. Does the table represent a linear or a non-linear function? So first, let's go find patterns. 3 to 6 is plus what? 6 to 9 is plus 3. Oh, awesome so far, right? Okay, we like this. Now what? Oh, ho, ho. That's beautiful. Is this a linear or nonlinear function? Linear. It is linear. All right, how about this one? Linear, nonlinear. Let's see. To get from 1 to 3, we did what? Plus 2. 3 to 5? Ooh, liking it so far, but uh-oh, what's happening down here? Minus 2. Minus 0. Had to. Okay, the y's made it all terrible, right? So, is this a linear or nonlinear function? Good. This is not a yes or a no question. So, for example, if you had this on the test and you wrote no, you're going to get it wrong because it's not a yes or no question. It's linear or nonlinear. It is.
I almost did that on the test, and I was like, I should probably put it.
The whole word? Good. Good. It's not a yes or no question. It's asking, is it linear or is it nonlinear? Because is it still a function? Yeah, it's still a function. It's just wondering if it's linear or nonlinear, which means this might be something crazy, like, right? Crazy, crazy. All right, you guys okay with moving on from 6.4? Linear, nonlinear, easy? Sweet. No, 6.5, this was our last section, okay? And this was it was kind of a strange one, I'm not going to lie, where it basically just wanted you to, like, talk about a graph, right? I'm going to be pretty lenient on how I grade these. And what I mean by that is, like, if you tell me, like, for example, let's say it says, compare the two sets of data. The population versus the time of Lake City. If you say, population goes up over time, I'm not going to give you your points, because does population go up over time? This graph is saying that there's some crazy stuff going on, right? How many segments are a part of this graph? 3. Now here are some of the big important words we need to use when describing graphs. Ready? We have the word increase. We have decrease. We have constant. And the word rate. What else? What other words do we have? Gradual. Do you guys like that word?
My word on the test is always so confusing.
How do you spell gradual? That's gradually. That looks really wrong. It's probably spelled wrong. I'm sorry, children at home watching this. I don't know, it just looks funny. Increase, decrease, constant rate, gradual. What's another word we could use? What if it's increasing quickly? Could I say it's increasing quickly? Could I just say that? I have no problem with that. What about, gradual kind of means slow. Would you guys agree with that? Okay, so it's kind of the opposite of quickly. Okay, so there are some very important words to use when describing graphs. I would write those down if I were you, because those words are the words I'm going to be looking for when grading these, okay? Segment? Yeah, you could talk about how many segments there are. Now, I know, Ben, last night you were emailing me confused on 5 through 8 on the quiz. This is 5 through 8 on the quiz, okay? So pay attention real well. If I said compare the two sets of data, the population, the time for Lake City, what would you guys tell me in words? What's the happening? How many segments do we have, first of all? I've got 3 segments, okay? Let's describe the first one. Okay, so constant means that the slope's going to be the same, right? It's decreasing at a gradual, constant rate. Would you agree with that sentence?
Yeah.
It's decreasing at a gradual, constant rate. Now, the word gradual means that it's going slower than, like, for example, I don't know, this, pretty fast, right? Now what happens on segment 2? Okay, and the reason why you're using the word gradual again is because compare it to this guy, right? So I would say then it starts to increase at a gradual constant rate, and then what happens? At a very quick, you could say increasingly increasing rate, right? That's the word they use in the book. Increasingly, or an increase at an increasingly rate. It's crazy. But yeah, it makes sense, right? It's increasing at a quicker rate now. Right? That's all you have to do, guys. Just describe to me what's happening. I think when you are given a graph that has segments like this, it's actually easier to describe than when you get a graph like this. Well, wait, hold on, let me find one. Like this.
Yeah, I just say it went up, and then, like, halfway it went down.
These are harder, aren't they? Because if you have segments, you can kind of like chunk it off into like, let's talk about this, let's talk about this, let's talk about this, right? But when it's one giant loopy segment like this, here's what I'm looking for mostly. I'm looking for the word not constant. Okay? Not constant. Constant means that there would be a nice straight line slope, right? Is this constant? No. So what is this comparing? This is comparing sales versus time for company B. This is saying the sales started here, and they were doing great for a while, and then what happened? Yeah. So you know what I would say to describe this graph? I would say company B had two peaks of really great sales, but then it goes down at a not very constant rate, and then they had one very low peak, okay? Like I said, I'm going to be very lenient on how I grade these, as long as you write enough. Does that make sense? Like, I wouldn't just say, company B had a rough time with sales. Or company B had some good sales, had some bad sales. As long as you're giving me some detail about this graph and describing it to me very, very detailedly, if I could read your definition and draw it without looking at it, that'd be great, okay? But I will be very, very easy with the grading on this, okay? How do you guys feel about these? Okay-ish? They're just kind of a pain, I think. They take a lot of time. When they're actually not that bad, it's just they're kind of a pain, right? Let's do this last one. Compare the two sets of data. I've got population, time, gold point. Obviously, gold point, it must be like a city, right? What's happening? How many segments are there first? 3 segments. What's happening in the first segment? Yeah, it's increasing at a very increasing rate. Then what happens? Ooh, I love how you guys use the word constant. What's staying constant? The time or the population? Good. Time is still going on, right? But population is staying pretty constant. Now what's happening in our last segment? Gradually decreasing. Very good. Yep. Maybe they're leaving, maybe they're dying, I don't know. Very gradual, right? So good job, guys. That's literally what I'm looking for, okay? How do you guys feel about this? Is there, in section 1, 2, 3, 4, or 5, is there a section that's more trickier than the other, or are you guys doing okay? How do you guys feel about creating the function rule? You guys doing okay with that? Remember, if you see a 0 in the x, that's your good. And remember, to find your slope, you take your y's first, subtract them, and then your x's and subtract them, okay? All right, so on page 282 in the book is a chapter test. It's a practice test, okay? I'm not going to go through it right now, but I do want you guys to look over it. So your homework tonight, we're going to do it right now in class. I'm going to stop the video. But you're going to do 1 through 10, okay? And this will prepare you for the test because the test is very, very similar to this practice one, okay? All right, if you have any questions, let me know.